All right, in our new unit, we're going to talk about perpendicular and angle bisectors. So the first word you need to know is equidistance, which means equal distance. All right. If a point is on a perpendicular bisect of a segment, then it is equidistance from the endpoints of the segment. So let's put that in a picture. If I have this triangle, that we get a perpendicular bisector right here, where those two sides are the same length. Bear with me, pretend those are the same length, okay? Then we also must know that the sides are the same. Okay. The second one says if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So if we're given a picture of a triangle with a line down the middle, and we're told that these two sides are the same, then we must know that this right here is perpendicular, that this is a 90-degree angle right there. Okay? All right. So if we had Mr. Lee wants to park his ice cream cart on Main Street so that he is equidistant from the entrances of the amusement park and the zoo, where should Mr. Lee park? There's the park entrance. There's the zoo entrance. If this is right in the middle of those, that's going to help us form our triangle. He should park right here on Main Street. I probably should have brought that in a little bit because he can't actually park in the road. So let's say he parks right here, so that he is equal distance from the park and the zoo entrance, because this is equal to that. And this is a perpendicular bisector. All right. Next. Oh, let me go over here. Let's look at just some examples with solving with x. So remember the theorem says that this must be equal to this. So 6x minus 10 equals 3x plus 2. We're going to combine our x terms by doing the inverse. We're then going to combine our constants by adding 10. And then we're going to divide by 3 to finally get x by itself. So x equals 4. Notice I have not answered the question. The question was actually, what is the value of AD? So that means I have to take that number 4 and plug that back in. So 3 times 4 is 12, plus 2 is 14. So AD is 14. Okay, this one should be the same. 6 times 4 is 24, minus 10. That is also 14. So yay, we did it right. But our answer to the question is 14. This one is the same way. You can set this side equal to this side so that your video isn't too long. I'm going to keep on going, but feel free to check your class notebook to see if you got that one correct. All right. What is the value of OL? All right, so this one just takes some reasoning. Since this is 9 and this is 9, I know that this, let me change colors. This little piece OL has to be equal to this little piece ON. All right? All right. Since this is equal to this, I also know that this length, yay, logical reasoning, has to be equal to the whole thing here. So if this is 14, this is 14. So NL is 14. OL is half of NL. So OL must equal 7. Okay, and to give you a little extra note there, this is because JN is 14 and they must be equal. All right, we're getting there, we're getting there. If a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So if I have an angle, and I have an angle bisector here, okay, any point that I pick drawing a line to the angle is equal to any point that I draw a line there at the same spot. Okay. All right, let's look at an example of what that looks like. That means that this must be equal to this. So I'm going to challenge you, like in that last example, set this equal to this and solve for x. Tell me what you get. All right, let's look at this one. If HI equals 7, first thing I'm going to do is actually write that number down to help me out. If IJ equals 7, oh, I know these must be equal. I know that HGI is 25 degrees. So what must IGJ be? Well, it must also be 25 degrees. What if I ask you, what is the measure of HGJ? Well, that would be the 25 plus 25, which is 50 degrees. And you are finished with your 5-1 notes.